A very common question in the exam comes where they ask you to describe a method that can be used to separate component of a mixture. So the different component of a mixture can be separated by physical means, and that depends on the nature of the mixture. If you have insoluble solid and you want to separate it from a liquid, then filtration is the method of choice. When this is called the filtrate, the liquid that is filtered, and this is the residue that remains on the filter paper, which is your solid. And then if you have a soluble solid and a liquid, then you can separate the solid using evaporation. You evaporate the liquid completely and only the solid remains. Or you can use crystallization. In crystallization, you only evaporate part of the solvent until the point of crystallization where crystals starts to form on the surface of the evaporating dish, and then you leave it to cool down and more crystals will form, and then you simply filter it. If you have mixture of solids and you want to separate the solids from each other, there is no liquid here, then that will depend on the difference in the solubility of the different component. So if you have mixture of sand and salt, the sand is insoluble in water while the salt is soluble in water. So you can dissolve both in water and heat it. So only the salt will dissolve, the sand will remain insoluble. So you can filter the insoluble salt and the filtrate will contain the salt solution. You can then separate the salt from the solution using crystallization. But if you want the liquid now, not the solid, and you have a mixture of a soluble salt and a liquid, then you can separate the liquid using distillation. So simple distillation is the method of a choice here. You heat the mixture where the liquid will evaporate, and then it goes through the Liebig condenser where it's condensed and it's collected here in the receiving flask. If you have mixture of liquids, you want to separate them, then you use fractional distillation. In fractional distillation, you use fractionating column, which has higher temperature at the bottom, lower temperature at the top here, and then as you heat it, only the vapors of the lower boiling liquid will reach the top of the fractionating column, goes through the condenser, and it will be condensed, so it can be separated. The thermometer will always display the boiling point of the liquid that is being distilled. The development of the model of the atom. The first scientist that described the atom was John Dalton, where he simply imagined the atom as tiny spheres that cannot be divided. Then the plum pudding model of an atom is a common question in the exam, where in the plum pudding model of the atoms has been described as a ball of positively charged uh, a ball of positive charge which have electrons embedded in it, which are negatively charged. So the mass of the atom is not concentrated anywhere, it's distributed all around the atoms, and the electrons are embedded within it. And this is different from the nuclear model for Ernest Rutherford, because Ernest Rutherford, when he did his experiment, he discovered that the mass of the atom is concentrated in the center of the atom, which is called the nucleus, and the nucleus is positively charged, and most of the atom is simply empty spaces, and the electrons are separated from the positively charged nucleus. They are not attached or embedded as the plum pudding model has described. And then Niels Bohr is the one who discovered the electron shells. So electrons orbit the nucleus in shells, and these shells are at certain distances from the nucleus. Finally, James Chadwick is the one who discovered the neutrons, which are the neutral particles inside the nucleus. His work was very important for the discovery of the isotopes because isotopes have different number of neutrons and they have different mass number. So the atomic structure and the subatomic particles, we know that the nucleus has the protons, which have relative mass of 1 and relative charge of +1, the neutrons, which have relative mass of 1, relative charge of 0, and then the electrons will orbit the nucleus from the outside here, and the relative mass is very small, so we simply neglect it, and the relative charge of the electrons is -1. The total number number of protons inside the nucleus equal the total number of electrons that orbit the nucleus. This is why the atoms are neutral. They are not charged. They don't carry a charge. A very common question as well is to ask you that they give you the atomic number or the mass number, and they ask you to calculate the number of neutrons, protons, and the electrons. So let's start with the definition. So when you define the atomic number, remember that atomic number is the total number of protons inside the nucleus. When you define it, don't use the electrons. Don't define it in terms of electrons. We define it in terms of protons. So the atomic number is the total number of protons, and this is also will equal the number of electrons in case of an atom. The mass number is the total number of protons and neutrons inside the nucleus. This is as a definition. So you can find the number of neutrons simply by subtracting the atomic number from the mass number. So mass number minus atomic number will give you the number of neutrons. Isotopes, these are different forms of the same elements which have the same number of protons, but they have different numbers of neutrons. So basically they have the same atomic number, but different mass number, like carbon 12 and carbon 13, which have different number in neutrons only. A very common question as well is that they give you the different isotopes, their mass, and their relative abundance, and I ask you to calculate the relative atomic mass. So you can use this equation, which is the relative atomic mass will equal the percentage abundance of isotope A times the mass of isotope A plus the relative abundance of isotope B plus the mass of isotope B, and you divide that by 100 because the total abundance will be 100. Then you can calculate the relative atomic mass. The electronic structure, to find the electronic structure or electronic configuration of any element, you can apply the electron shell rule. The electron shell rule states that the electrons will always occupy shells, and these shells will increase in energy as you go further away from the nucleus. Each electron shell has a maximum capacity of electrons, and you have to fill the electron shell with lower energy first before you move on to the next one. The maximum capacity of the first shell is 2 electrons, the second shell is 8, and the third shell is 8. So if you want to write the electronic configuration, for example, for something like carbon, which has 6 electrons, then it's going to be 2 and then 4, because the first one have maximum capacity of 2, the second one will have the remaining 4 electrons. The development of the periodic table, Dmitry Mendeleev, is a very common question in the exam. So what did Dmitry Mendeleev do? Dmitry Mendeleev is the scientist who has created the periodic table, the first periodic table, and which has been developed later on to the modern periodic table. What he did is that he took the 50 elements that were known at that time, and he arranged the element in order of atomic mass. He didn't arrange them in order of atomic number, because the atomic number is the number of protons, and the protons were not discovered at this time. He kept the they kept the elements or arranged them in certain groups or certain columns, and to fit a certain properties where the elements in the same group have similar properties. Sometimes he switched the order of some elements because he wanted to make them fit the properties of the same group. He left some gaps in his periodic table, and elements later on, when they were discovered, they fitted well in these gaps. And then the modern periodic table, it's different from Mendeleev 1 in the fact that elements were arranged now in order of atomic number, not atomic mass. They have been arranged in periods, which are the rows, and the elements in the same period, they have the same number of electronic shells, but the properties changes along the period. However, elements in the groups, which are these columns, they have the same number of electrons, of outer shell electrons, and they have similar chemical properties. So we have group 1 elements here. They all have 1 electron in their outer shell of electrons, and they have similar chemical properties. group 2 element, they have two electrons in their outer shell, and then the group at the far right of the periodic table is called group 0 elements or noble gases, and they have full outer shell of electrons. How to find metals, nonmetals, and transition metal in the periodic table? The metals can be found on the left-hand side here on the periodic table. These are metals. Non-metals can be found on the right, the green ones, right and top ones. These are the non-metals. And then transition metals can be found in the center of the periodic table. The group 0 elements or the noble gases, these are the group of elements that we can find them on the right hand side of the periodic table. They have a full outer shell of electrons, and because they have full outer shell of electrons, they are inert, they are non-reactive because they cannot gain or lose electrons because they are stable. For their physical properties, the boiling point of noble gases will increase as you go down the periodic table because the size of the atom will increase and the atomic mass will increase, which means the forces of attraction between the particles, the intermolecular forces of attraction between the particles will increase, so more energy will be needed to separate these particles. Also, the group 0 elements exist as monoatomic because they don't share electrons or they don't gain or lose electrons. And then group 1 elements, which are called the alkali metal, you can find them on the left-hand side. They all have one electron in their outer shell, and because they have only one electron, they tend to lose this electron to form positively charged ions with +1, like sodium in this case. And usually they react with non-metals, where the non-metal will gain that electron to give negatively charged ions, and there will be electrostatic interaction between the oppositely charged ions and they form ionic compounds. As you go down the group, the element will become more reactive, and the reason behind that is because the outer shell electrons become further away from the nucleus, which is positively charged, so they will be less attracted to the positively charged nucleus, so the electron become more easy to be lost, or the element will lose the electron more easily. So this is why they are more reactive. If we talk about the physical properties here as well, as we go down because of the size of the atom increase, then also the melting point of the metal will increase. This is because increase in the size means that intermolecular forces between the particles will increase, so more energy will be needed to separate these particles. As for their physical properties as well, they are soft and they have low density. For their chemical properties, they are very reactive, so they react with water vigorously to produce hydroxides and hydrogen gas. As you go down the periodic table or the group for the alkali metal, they become more reactive, so the reaction becomes more violent. Also, they react with oxygen to give metal oxides. They react with halogens like chlorine to give metal chlorides. Group 7 elements, which are called halogens. These are the group 7 elements. They have 7 electrons in their outer shells. They exist as diatomic molecules like fluorine, chlorine, bromine, and iodine, all diatomic as we can see. And then because they have 7 electrons in the outer shell, they can easily gain one extra electron to form a negatively charged ions. They tend to do that when they react with metals and they form ionic compounds with metals because they gain the electron from the metal, which loses the electron to give the positively charged ion, and there is an electrostatic interaction between the oppositely charged ion to form ionic bond. They also can share electrons with other non-metals. So with non-metals, they share electrons to form covalent compounds. As we go down the periodic table looking at the reactivity trend, as we go down, the reactivity will decrease. The reason behind that is because the size of the atom will increase, and as the size increases, the outer shell electrons becomes further away from the positively charged nucleus, so they will be less attracted to the positively charged nucleus, so they can gain electrons less easily as you go down because the size becomes bigger. And if we look at the trend for their physical properties as well, like their melting points and boiling points, as you go down, the melting points will increase. So let's look at their physical properties. So we have fluorine and chlorine, the first two, they are very reactive and they are poisonous. And they are gases. And then we have bromine, which is liquid at room temperature. It's also poisonous. So if you have any reaction that you use any of these halogens, you should do it inside a fume cupboard because these are toxic compounds. And then we have the iodine, which is solid at room temperature. As you can see, as you go down, the melting point increase, and the melting point increase because of the increase in the size. So there is an increase in the intermolecular forces of attraction between the particles or between the molecules. So they need more energy to separate them. One of the common reactions for halogens as well is the displacement reaction, where the more reactive halogen can displace the less reactive one from its salt. So you have chlorine can react with potassium bromide, which as bromine is less reactive, to give potassium chloride, and then you have bromine. You can notice the change in the color of the solution as the reaction goes. Finally, there is the transition metal. The transition metal can be found in the center of the periodic table. A very common question is they ask you what is the difference in the properties between transition metal and group 1 metals. So they differ in their physical and chemical properties. The difference in the physical properties can be seen as they have higher melting point, they are more dense, and they are harder. And for the chemical properties, they are less reactive, they form different ions, and they form colored compound, and finally they can be used as catalysts.